Welcome to Chapter 4 of our series. Today, we are examining social media analytics, drawing from the framework taught at the University Utara Malaysia School of Computing. When everyday users look at social media, they see posts, likes, and comments. As computer scientists, you need to view it as a massive, continuous, and highly chaotic stream of unstructured data. To make sense of this noise, we have to route it through complex computational pipelines. By applying data analytics, machine learning, and artificial intelligence, we can parse out the relevant signals and output perfectly structured rows of data alongside clean visualizations. Mastering this specific transformation process is exactly how organizations turn raw digital chaos into a measurable, actionable strategy. Let's establish our technical baseline. This is social media analytics, the overarching computational process of collecting, measuring, analyzing, and interpreting social data. Underneath that umbrella, we split our focus into two distinct categories. On one side, we track social metrics, which are strict quantitative measurements like view counts. On the other side, we deploy social listening, the qualitative monitoring of online conversations. All of this feeds into business intelligence. We visualize the process data on a dashboard, a graphical interface designed to give decision makers an immediate, comprehensive read on system performance. Without this shared taxonomy, software engineers cannot effectively build the tools that marketers and executives rely on to do their jobs. To build those tools, we rely on a systematic 5-stage data architecture known as the Social Media Analytics Framework. The pipeline starts with Stage 1, defining clear business objectives. Without a target, you are simply hoarding useless data. Once the target is set, Stage 2 triggers data collection. We scrape raw interaction and behavioral data directly from platforms like Facebook, X, and TikTok. But that incoming data is full of noise. Stage 3 is data preparation. This is the computational scrubbing phase, where the system executes scripts to remove duplicate records, filter out spam, and standardize text formats. Stage 4 is data analysis. Here, the heavy computational lifting occurs, broken down into 4 distinct algorithmic approaches. Path 1 is descriptive analytics, calculating what happened, like tallying total likes. Path 2 is diagnostic analytics, which correlates data to answer why did it happen. Path 3 introduces machine learning for predictive analytics, forecasting what will happen next. And Path 4 is prescriptive analytics, using optimization algorithms to recommend what you should do about it. Let's test this logic. If Netflix uses a machine learning model to calculate the absolute best time of day to post a new trailer to maximize views, which of these 4 analysis types is being used? It is prescriptive analytics. The system outputs a recommended action based on an optimization algorithm. Raw data scraping has 0 value unless it is systematically pushed through all 5 of these stages to finally generate Stage 5, an actionable insight. This chart outlines the specific tech stack we use to automate the pipeline. At the base, we pull from native platform APIs. In the middle tier, we route that data through third-party aggregators like Hootsuite. At the top tier, we deploy advanced AI systems. That top tier is crucial. We use natural language processing, or NLP, to parse blocks of human text. These algorithms scan user comments, classify public opinion by highlighting positive and negative words, and calculate an automated sentiment score. Organizations generate millions of interactions daily. Manual review of this data is mathematically impossible, making AI integration mandatory to scale the analytics pipeline. Let's look at the strict mathematics driving these metrics. This split screen clarifies a common error. Reach on the left counts unique user IPs or accounts. 1 user equals 1 count. Impressions on the right counts total display executions. If that same user refreshes the page 3 times, it generates 3 impressions. To measure actual audience interest, we use the engagement rate formula. We take total engagements, divide by total reach, and multiply by 100 to find the exact percentage of unique viewers who actively interacted. From there, we swap to the click-through rate formula, dividing clicks by impressions to track link navigation. Finally, we calculate the conversion rate, dividing successful conversions by total visitors to see how many users completed a desired action, like a purchase. These formulas are straightforward arithmetic. The true value of a data professional is knowing how to use these outputs to diagnose complex business problems. Let's run a diagnostic. This dashboard displays a massive spike in reach, but a tiny bar for engagement. Thousands saw the post, but almost no one interacted. This points directly to a problem with content relevance or quality. Now the dashboard shifts. We see massive engagement, but an abnormally low conversion rate. Users clearly like the content, but they are not making a purchase. This diagnoses a failure in the user interface or a weak call to action. Finally, observe a scenario with massive engagement numbers. When we overlay the NLP module's findings, we detect a high negative sentiment score. High engagement during a wave of negative sentiment indicates a PR crisis, not a successful campaign. Isolated quantitative numbers lack context. Without the qualitative analysis provided by AI sentiment tools, an organization can easily interpret a disaster as a success. Here is your master system summary. The complete pipeline moves from defining strict objectives through algorithmic data preparation to rigorous AI-driven mathematical analysis. As computer science students, you are the architects of these systems. You build the pipelines that filter the noise, train the models that parse the text, and transform digital interactions into strategic business advantages.